All right. We've learned previously that when you're interpreting an IR spectrum, that you want to focus initially on the left half, namely on the peaks associated with stretching motions, and to ignore the right half, ignore the peaks associated with bending motions. However, there is information in the bending region in certain circumstances. If the stretching peaks in your IR spectrum point to an alkene or aromatic group, the peaks in the bending region can tell you more detail about the structure of the alkene and the aromatic ring. Specifically, the alkene, for example, bending peaks will tell you if you have a cis isomer, a trans isomer, or if the double bond is at the end of the chain, and so forth. If you have an aromatic ring in your compound, bending peaks can tell you if you have a single substituted aromatic ring or disubstituted, and what the possible pattern of disubstitution is. Remember in class we talked about the fact that disubstituted benzenes, there are three possible isomers: ortho, meta, and para isomers. Ortho, meta, and para isomers. The bending peaks can tell you whether your substituted benzene, your disubstituted benzene, is ortho, meta, or para. Let's look now at an example. Here is a spectrum that we've seen before, the spectrum of our alkene with a six-membered ring. Let's examine the peaks associated with the double bond. CC double bond, this carbon has hydrogens. Those alkenyl CH hydrogens create this peak here. The alkenyl CH stretches produce this peak. The CC double bond stretch produces this peak, about 1640. Now the peak at the far right is a bending peak associated with the HCH structure, namely at the double bond. Its frequency has a bearing on the structural type of the alkene. Now this alkene has a structure type that's called an alkylating structure. An alkylating structure is an alkene in which one alkene carbon has two hydrogens and the other alkene carbon has two carbons. This frequency peak here, in fact, is going to tell you that. Let's now look at the table of IR frequencies, the structural units and absorption frequencies table. Let's look at this portion of the table. These are all bending peaks associated with a carbon-carbon double bond. All right, first entry we look at is this. If you have a alkene at the end of a chain, then in the bending region you will see, the table indicates, two peaks. The first one is on an average 980, the second one an average of about 920. If you have an alkene with a cis geometry, the bending peak that you will see for that is between 650 and 790. Fairly broader region, but it does produce a peak in that region. If you have a trans double bond, it produces a single peak in a different part of that spectrum, though, from 940 to 990. We mentioned the alkylating structure in our example alkene. If you have an alkylating type structure, then that will give rise to a single bending peak centered at about on average 900, 870 to 915. So if you have determined that your unknown has a carbon-carbon double bond. And you're going to do that by examining, remember, the stretching motion values. If you determine from the stretching bands that you have an alkene, the peaks in the bending region here will allow you to determine the detailed structure. Is it cis, trans, alkylating, or what? Well, let's go back to that spectrum here. This peak here is, as we indicated, the HCH bending peak. Its value is, I estimate, about, I want to say 880, a little bit below 900. So remember that value. Ignore this little peak right here, but basically one peak in that alkene bending region let's see if that corresponds to the alkylating bend. Indeed, you can see it does. An alkylating structure has one peak, 870 and 915. That corresponds to what we have. So if this were an unknown, you didn't know what the structure was, you determined that it's an alkene, the existence of a peak around 900, a little bit below in our spectrum example, tells us that, we have an alkylating structure because we don't have a double bond at the end. That would be two peaks around 980 and 920. We don't have that really. We don't have a cis double bond. We don't have a peak 650 to 790. And we don't have the trans, which is 940 to 990.